So we're going to talk quickly about conditions of equilibrium. They're very, very simple, and, well, they're simple to state and desperately complicated to actually use. But the whole idea is the sum of forces is zero. It's no translation, so this is no translation. And the sum of moments is zero, so that means there's no rotation. Okay? We have our main assumption that we're going to do here is to say that there's no deformation. So formally that's like the distance between the internal points of the such and such don't get any closer or further apart or whatever. But actually this is a pretty reasonable assumption at the moment. It's pretty good. It's a pretty good assumption for like steel or concrete. Those are it's pretty reasonable to expect that it doesn't deform under normal usage. So I realize that me doing quotes in the air is not that helpful to you. So basically we're going to start off in 2D, and then we're going to go into 3D. So what we're really going to focus on here is the idea of support reactions. So basically the idea is if, I'm got something going on here, like a fixed support sticking out of a wall, what are the support reactions at the whatever you call the condition where they meet at the right there? Yeah. So looking at support reactions, there's a couple of things to keep in mind. If a support, let's see, how do I say this? So we say if a support prevents translation, if it prevents translation in a certain direction, then there's going to be a force. Then there's a force developed in that direction. So kind of looking at the idea of a fixed support here, it's preventing me from going down, right? This point is being prevented from going down, so I could say there's a support reaction pointing up on there. Now, if a support, say, prevents rotation, in a certain direction, I'll just say if a support prevents rotation, then there's a moment, like a reaction moment in that direction. Okay, so I guess I kind of drew it backwards, and rather than saying in that direction, it's probably better to say in the opposite. It just depends on what you're thinking of. But basically, instead of going down, it won't let me go down, so I have a support reaction going up. Actually, another support reaction over here is it won't let me go to the left, so I can say I have a support reaction going to the right. On the same example, it's not letting me rotate down, so I can say that there is a reaction moment that's preventing me from spinning down. Okay? So does that kind of make sense? And then what we're going to go from here is we're going to actually go look at all the different kind of support reactions that you can have. Now, as a quick note, we don't want to include like what you would call internal forces, because they're like, they all cancel out. And the reason they all cancel out is because we assume that there's no deformation. So if there's no deformation, all the internal forces cancel out, so we don't even bother labeling them. Another thing that we do, so we don't include internal forces, and we kind of assume the cow is spherical. So we assume a center of mass. Well, I mean, everything obviously has a center of mass, but we're going to draw the force there, is where the weight comes out of, if that's helpful to say. We assume a center of mass where the weight comes through. So even though we might have a block like this, and in theory every single little mass particle thingy in the whole block goes like this, we're not going to do that because that would be very annoying and it's actually entirely unnecessary. We're just going to assume that the weight occurs at the center of mass right there, mg, at the geometric center. So a couple of things to keep in mind as you're going along is remember that the couple moments are free vectors. So we can place those anywhere. And that, again, forces can act at any point along their line of motion. And if you got those down, then you're in pretty good shape. But we will go through and look at a bunch of support reactions just so you can get some good experience interpreting those and being ready for them.